We were in the 2011 measurement and molds in the introduction, and we have looked at the booklet. You can have a docx version or a PDF version, and you download the PDF answer guide. And then also, if mics can be off, unless you want to ask a question. So this is what the booklet looks like. And although it says only for the standard, it does cover for other things. In terms of calculations, if you think of when you want to work out sort of percentage this or that or the other, you normally can sort of count things. But with atoms, they are just too small to count. You can't look at a pen and say, I've got 20 atoms in this blue part of the pen or something like that. They are just too tiny to see. So we can't actually physically see atoms, so we can't count them. So the way we count atoms is by their mass. So we first weigh them and then say, okay, each element has a different mass. So by knowing what the exact elements are in this blue pen, I can work out how many atoms are in this blue pen. So that's the very first basic thing you need to know about when you want to do any calculations, is try and get that relationship between mass and the number of particles. So the way this booklet is done is this front page has a whole lot of hyperlinks. So if you want to do the first bit, you go Control, and it takes you straight there when you click on it. So the first thing you need to do is know your elements. Now, you don't necessarily need to know them off by heart, so you don't have to go hydrogen, helium, lithium, beryllium, boron, blah, 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 like a party trick. Well, you're welcome to. But you do need to be able to look at a formula and recognize what they are, what those symbols mean. So a good way of learning these is by, if I just click on here, is making up a table and drawing up all the names of the elements. You need to know for level 2 the first 20 elements plus a few others. So you need to know lead, barium, copper, iron, and there are a few zinc that you would need to know. So they are in the Quizlets, but one way is just to write down the name, and then once you've written down the name, because you just copy that from the periodic table, to then do the symbol. And then once you've written down the symbol, cover the name part. So you cover this first column and see by looking at the symbol, can you write down the name? And then you cover the symbol part and then look at the name, can you write the symbol? If you keep on repeating that, and handwriting it and not just typing, although you could type as well, handwriting makes it sort of stick in here more, then you will learn those. So it's really important you know that. Now, I know some of you will probably know these elements backwards, others are still starting to learn it. Can I just ask for people to mute their mics just to stop the background noise? So if you can just check your mics to see that it's muted. Now, I did have in the booklet, the other way is learning by Quizlets. If you have used Quizlets before, they can be quite fun. So I've got here some Quizlets opened up. So you can either do it using this one, that's the one link I gave you, or the other link. So you can either do it by flipping it and then going to the next one, and getting flashcards, or you could play games. So for instance, like the match game. So you can race against yourself. And so for instance, okay, there's a time going, I'm going to be pretty slow. You can go, okay, chlorine, and then it's Cl. The beauty about this, it also shows you the colors. Okay, and it shows you that nitrogen's a gas. Nitrogen doesn't look purple. It's just that's the color it gives off if it's excited. So gold is Au. Okay, calcium is Ca, nitrogen is N, boron is B, and hydrogen is H. So, you know, you can just play games like that. So that is a really important thing. Now, any questions so far? Whoops. Where was I? I was supposed to go over here. Apologies for that. Any questions so far about learning the elements? Because you do need to know them. Spend a bit of time to make sure you know those. Okay, so once you know the elements, then you will be given formulae to work with. So I won't sort of say how many atoms are on this blue pen because that's a bit too vague. I would give you a formula. I could say how many atoms is there in this glass of water, because water is H2O. We're going to assume it's pure water, and we could weigh the water in the glass and get the mass of the water that's in there, and then we can work out exactly how many molecules of water is in this glass of water. So we need to know how to look at a formula and work out the ratio of the atoms in there. So as an example, what we've got here is sodium sulfate. And you'll notice when we write formulae, there's this little number that is subscript that's on the bottom right next to some of the elements. So hopefully once you know your elements, you'll know that's sodium, you'll know that's sulfur, and you'll know that's oxygen. Now it's very important, each corner of an element means a certain thing. So the bottom right corner of an element is reserved for the ratio or the number of those atoms. So here, for instance, sodium, it's got a 2 next to it, which means I've got 2 sodium atoms. The oxygen has got a 4 next to it, so I've got 4 oxygen atoms in this substance. And the sulfur has got no number next to it. Chemists are lazy, so if they can avoid writing something, they will. So a 1 is always assumed. So in like equations or formulae, if it's just one thing, then we don't bother writing the 1 down. So there's 1 sulfur atom, 2 sodiums, and 4 sulfates. So have a look at this next formula. Okay, so I've tried to just do that visual thing over there. Have a look at this next formula. I'm going to try and hide some of this. How many lead atoms? Lead is Pb. So if you want to just type on the chat, hopefully there'll be lots of things. How many atoms of lead are in this molecule or in this compound? It's not a molecule, it's a compound. Right, there's 1. Great. Okay, now we get to a tricky bit. Oh, great. Everybody's coming in there. Now we get to a tricky bit. I have got how many, now I'm not going to do elements, I'm going to do the group. How many groups of NO3? Now NO3 is given the name of nitrate. How many nitrates have I got? 2 of them, correct. Okay, and I could work out the mass of nitrate and double it, you know, for the 2. But we're just working by elements now. So if you can imagine 2 nitrates, how many nitrogen atoms have I got in this substance? 2, okay? Because I've got a 1 next to the N, but the brackets means this 2 outside is everything inside those brackets. So 2 times 1 is 2 nitrates. How many oxygen atoms have I got? Great. Okay, 6. You're all doing well. And sorry if I'm teaching you to suck eggs and you all know this, but I do want to make sure these basics are correct. So it's quite good to draw this visually for those that weren't sure. So if you, excuse my hand, so if you think of, I've got 2 nitrates, you can see that I've got 6 oxygen atoms and I've got 2 nitrogen atoms, because a lot of people add the 2 and the 3 and they come up with 5, but remember it's 2 nitrates, so I've got 6 oxygen atoms there. Right, so The way then this goes is I give you an examples and then you will try these out. If you find them easy, just do the first few and the last few because they're always done to try and make it go more difficult. If you want more examples, ask your teacher. And as I say, as we do these lessons, I'll be giving more examples for the more complicated calculations we do later in case you need more than that's given here. But let's have a quick check. How many, based on this, you can see I've got 1 carbon and 4 hydrogen atoms in methane. So CH4 is methane if you've done any organic chemistry. What about water? How many hydrogen atoms in water? 2. Brilliant. Great. This is like a Kahoot. How quickly can you press the thing over there? Oxygen. How many oxygens? Yeah, I see somebody's really quick on there. Good. And then let's go down a bit. Okay, and oops. So we're going to go a bit up. Let's go over here. Now this is going to be a little bit on the trickier side because we made the trickier ones down at the bottom. Let's see if I can trick anyone with this one. This is ammonium nitrate. It's used as a fertilizer. It was the one that gave that big explosion in Beirut about 2 years ago and caused a lot of damage and death. Ammonium nitrate is very, very explosive, and it is used as an explosive as well as a fertilizer. How many nitrogen atoms are in ammonium nitrate? Great. I wasn't able to trick anybody. Okay, you can see there are 2 because there's 1 there and there is 1 there. So in a formula, if you've just got a straightforward, what we call a molecular formula, that that's not quite the right word that I want to use. But anyway, they often lump all the elements together. So it would be like N2O3H4. But often in compounds, we write it out the way that those atoms are connected. So I've got 2 nitrogens here. This nitrogen is connected to hydrogens and this nitrogen is connected to oxygens. So you should know all this one. How many hydrogens have I got? 4. Great. Okay. And I won't ask oxygen because I can see this is easy. If you're looking at this one, then how many carbon atoms have I got? Brilliant. Can't trick you. How many hydrogen atoms have I got? Yep, 6, correct. Yep. So again, it's because the hydrogens are spread out. I've got 3 there, I've got 2 there, and I've got 1 there. So here we add the hydrogens because there are no brackets in here. You only multiply when you've got brackets. So if I go to this one down here, how many oxygen atoms do I have in iron 3 nitrate? 9. Okay, so when you just see something like this without brackets, you add them. When you see something with brackets, you multiply them. So hopefully that's now all clear to everybody. And then I'll leave this one for you as a challenge to do when you get round to doing this booklet, because everybody that's going to be continuing on with chemistry has to do at least the first 2 stages in this booklet. Right, so that's going well, because that might look easy, but it's the most important thing. If you can't do this, you're not going to do well. Okay, the next thing is, okay, now that we can look at a formula and count how many atoms there are, that formula only sort of represents something. It still doesn't tell me how many atoms are on this pen or how many atoms are in this glass of water. So because your atoms are so tiny, I mean, they really are incredibly tiny. We can't actually, even with the most powerful microscopes, see them. We can, the closest we've got is to sort of see an effect of them, is we have come up with a term that we use to represent a group of atoms. So if I talk about a pair of shoes, you know exactly how many shoes you've got. So how many shoes would you have in a pair of shoes? 2, right? Okay, you would know because the term pair means 2 shoes. If I talk about a dozen eggs, how many eggs have I got? You know, you've got 12 because dozen means is a term to represent the number 12. If I said I had a score of candles, now that's an old-fashioned term, score. Does anybody know what's 20? Great. Okay. So if you had a score of candles, you're 20 years old if they're on your birthday cake. Or if somebody said a batsman had a century of runs, how 100? You're onto it. Okay. So in English, it's quite common to have a term that represents a number. So in chemistry, we also have a term that represents a number. And don't ask me why. I sometimes think there was a whole bunch of chemists sitting around having a whiskey or something and decided to come up with the term mole, M-O-L-E. It might have been because it's short for molecule. Let's give them benefit of the doubt, but I'm sure they sort of sat around and decided to come up with a weird name. So it's not the furry little creatures or perhaps any dark lumps on your skin, you know, that we know as moles. A mole is a term we use to represent a number, and it is an enormous number. Okay, that is, you know, I suggest you watch this clip just to get your head around it and then forget about it. Just make sure on your calculator you can use this exponential button, okay, because that's what you're going to need if you're working with, if you wanted to be asked the exact number of atoms there are. In chemistry, we don't really ask how many exact number of atoms because we know they're just so tiny, so we tend to group them as mass. An idea to show how big this number is I did this when the population was about 7 billion people. It's now getting closer to 8. But even so, if I had 1 mole of dollars, doesn't sound like a lot, 1 mole of dollars, but it mean, and I dished it out to every single person on earth, man, woman, and child, it would mean that every person would be a multi-trillionaire. So that might give you an idea of how big this number is. Okay, so it gives you also an idea of how tiny an atom is, because there is, I haven't measured this, but it's more than 18 grams. So this is probably around about 2-3 moles in here in this mass. Okay, so that's a heck of a lot of particles in there. Right, we are pretty much finishing off now. I did want to just get to this idea of, a mole. And basically what we are saying that then whenever you get a formula, and we are told, you know, if those represent a mole, then just how we count it. So if I go back to over here, so this would be then I'd have 1 mole of iron atoms and 3 moles of nitrogen atoms and 9 moles of oxygen atoms for every 1 mole of iron 3 oxide. So I think we'll just sort of, that's a good place to stop, because the next bit is going to be going into moles in a bit of depth. So hopefully that was a nice easy start to calculations in chemistry, and then we'll see next week how we can use moles and actually work out then, you know, how to count atoms using the moles. Any questions before we finish up? Did anybody have technical issues coming in? Okay, for those questions, do we do this work alongside? No, you're welcome just to sit in and for the lessons, and then do this work when you're ready for it. So if you say busy with redox, or if you're busy with the 2001 that everybody starts off with, just keep on doing that and get that done. It just means when you get round to doing this booklet, you are, hopefully this will all be familiar and you'll be able to go through it a lot more quickly. So don't feel as though you've got to get this done as well as your other chemistry work. Okay, right. So we'll see you next week. And so the Microsoft Teams, was it better than the Bongo? It did mean I had to admit people. So it was a little bit disruptive in the beginning, and I hope there weren't too many technology challenges. But hopefully you can also see more. I'm hoping it was a clearer picture that you could see. Yes. Okay, right. I'm going to just stop sharing my screen. Oh, sorry.